Good morning. Welcome to my channel once again. Please subscribe, like, and share the videos to motivate me to produce more videos like this. The last time we looked at how to determine the ground state term for a P1 atomic orbital. Today, I want us to continue with how to determine the ground state term for a P2 atomic orbital. As usual, we have to write down the angular orbital quantum number. For P orbital, it is 1. Then the magnetic quantum number. The magnetic quantum number for P orbital is +1, 0, and -1, because magnetic quantum number begins from +L, 0, and -L. Since the L is 1, we begin from +1, 0, and -1. Then the spin quantum number, represented by ms. An electron can spin upwards, which is represented by +half, or downwards, which is represented by -half. The next thing is to write down the orbital. The p orbital is a 3-degenerate orbital. Then we indicate the magnetic quantum number. Then we fill the orbitals with electrons. We have 2 electrons, so we fill with electrons by obeying the rules in filling orbitals with electrons. So here we obey the Hofbauer rule, we obey the Pauli's exclusion rule, and the Hans rule. According to the Hans rule, if we have the degenerate orbitals, then we should fill the orbitals with 1 electron in the same spin before we begin pairing up in opposite spin. Since we have 2 electrons, 1 electron here and the other one here, all in the same spin, no electron remaining. The next thing is to calculate the total orbital angular momentum, which is represented by ml. The total orbital angular momentum is determined by summing up the magnetic quantum number of the orbitals that contains electrons. This orbital contains an electron. The magnetic quantum number is 1. This also contains an electron. This is 0. And they all have only 1 electron. So the total is 1. Then we determine the total spin angular momentum. The total spin angular momentum is determined by summing up the spin quantum number of each electron. We have 2 electrons. This electron is spinning upwards, so the spin quantum number is +half. This is also spinning upwards, so +half. So +half, +half, we have a total of 1. According to the previous video, if we have the total orbital angular momentum to be 1, then we have a p term. If it is 0, it is an s term. 1 is a p term. So our term is a p term. Then the spin multiplicity is 1, so 1p. Therefore, the ground state term for a P2 atomic orbital is 1p. Thank you.